All right, so good morning, everybody, and welcome back to Exploring by the Seat of Your Pants. If you're joining us for the first time today, we are all about bringing conservation, adventure, and science into classrooms around the world. And it has been so nice having you in the month of January. This is obviously our last day of the month. We will have done 25 to 30 programs of scientists and explorers all around the world. And I know it's the strangest time to be a student or teacher in today's world. So thank you all so much for joining us as we continue to showcase and celebrate such amazing people and places around the globe. Now, today, I do want to note too, for any of our teachers joining us, we did just put out our new newsletter. So if you want to head to our website at exploringbytheseat.com, you'll see all a bunch of amazing programs coming in February. Now, February is our entire month dedicated solely to amazing women in science and exploration. It is going to be incredible, and I really hope you guys get the chance to join us for that too. Now, in today's program as well, just a quick housekeeping note, we are going to be having a Kahoot quiz. So whether you're joining us live or on YouTube, if you want to open up kahoot.it, kahoot.com, and a separate tab, I'll give you guys the game pin at the end so we can all play along together in a little quiz to test your understanding and have a little bit of fun in the process. Now, today we are joined by one of my very favorite speakers from last year, and that is Chris Derksen. He is a research scientist for the Climate Research Division of Environment and Climate Change Canada, where he gets to go to the edges of the earth, to the Canadian Arctic, one of the most amazing, austere, beautiful landscapes on this planet, to go understand more about the snow and ice up there, to understand how that is being affected by climate change. So it's tying together epic exploration, amazing landscapes, really cool science, and climate change in the Arctic. So some of our biggest, most popular topics here as an organization. So without further ado, I'm going to turn it over to Chris to blow your minds over the next 25 minutes or so. Thank you so much for joining us today, Chris, and take us away.
Great. Thanks for the introduction, Jesse, and thanks everybody for joining. I'm really thrilled to be able to talk to you today about some of my own research and work that I do in the Canadian Arctic, measuring snow and ice. And I often do these visits directly in schools. And when I do that, I bring some of my gear with me, my quality Arctic bomber hat, my big Arctic mitts. So I have them with me in the room here to help set the mood. I have my field guide to measuring snow. So I've got myself all sharp and ready to go. So I'm really happy to talk to you today about one of my passions in life, which is going up to the Arctic, traveling in some pretty remote areas and measuring snow and ice. So I'm based in Toronto. I work for Environment and Climate Change Canada in the Climate Research Division. And yeah, I'm really thrilled to be able to talk to you today about my job. And we always say when I'm in the Arctic that we can't believe we get paid to do this. So I'm really fortunate and privileged to be able to spend some of my time with some amazing people in Northern Canada. So let me just figure out how to advance my slides. There we go. So what's my job? Well, I lead a research team that uses satellite data and climate models to understand how climate change is impacting the Arctic. I'm not going to talk to you at all today about satellite data and climate models. What I'm going to focus on is doing work in the field, going into the Arctic and making measurements on the ground of snow and ice. That's the most fun part of my job. That's what got me energized about this type of work when I was a student. And I'm really thrilled that I'm able to continue doing that through the present day as well. So this is a picture in the Canadian Arctic of me and some of my colleagues. We found a really big old chunk of ice that we went to visit and check out. And so that's the kind of photo that captures what I like about my job. I thought I'd take you back in time a little bit too. I've always had an interest in snow and ice. This is a picture of me when I was, I don't know, 5 or 6 years old, maybe, with a pretty terrible igloo that I tried to build in my backyard. I guess I got the walls up. That's a good thing. But I always had a pretty strong interest in snow and ice, even when I was a little kid. Let's see. And then I first went to the Arctic in 1994. These are some older photos that I found recently when I was looking a little fresher of face in my younger days. I was lucky enough to go up to the Arctic when I was an undergraduate student. And I really got a passion for it and got hooked in from that first experience. And I've been lucky enough to keep going back to the Arctic almost every year since 1994. We've had some interruptions in the past couple of years because of COVID, but we're hoping that we're going to be able to get up again this spring. So why am I interested in snow? What is it about snow, especially in the Arctic, that's so important? And I really think snow is a fascinating material for a number of different ways. First, you get these beautiful snow grains that fall. This is a colleague of mine drew this artwork on the right. Snow falls in many different shapes and crystal sizes and types, depending on what's happening in the atmosphere when it forms. Then it lands on the surface of the earth and it blows around and gets interacted with the vegetation, topography, and it really changes its character over the snow season. So I'll talk a little bit about that briefly. Snow is important because it stores water in solid form, fresh water, and then when it melts in spring, it releases a pulse of that water into the environment. Snow, as anyone who lives in a cold region knows, it's really bright, right? So when energy from the sun hits the snow, it's reflected back out into space. So having snow on the ground actually helps regulate the temperature of our planet. It helps cool off our global climate system. Snow is a great insulator. It's like a blanket that sits on top of the land surface. It keeps soils beneath the snow much warmer than they would be in the winter if it wasn't for that snowpack on top. And then, of course, there's lots of animals. Some of them live in the snow. Some of them, like caribou and polar bears, live on top of the snow and have to move through it. So it's a habitat. So it's really interesting to keep that aspect of snow in mind as well. And of course, snow responds very directly to global warming, to climate change. So we know you can't argue with the melting point of snow and ice. When temperatures get above zero, snow will melt. And so we're seeing a real direct response across northern regions of how snow is changing because of climate change. For those of you in Canada, I'm showing a plot here that this is the only graph I'm going to show today, but it just shows how Canada has warmed about 1.7 degrees Celsius or 3 degrees Fahrenheit since 1948. This is about 2 times the rate of global warming. So the global temperature change is the red line on this plot. Temperature change in Canada is the blue line on this plot. And then the black line on top is the Canadian Arctic. It's changing even faster, about 3 times the rate of global warming. So our northern regions are changing faster. They're experiencing the impacts of climate change more than anywhere else on the earth. So some questions to think about before I talk to you a little bit more about some of my direct experiences in the Arctic. Some questions to think about, sort of why it's important to measure snow to understand snow. When you're outside walking in the snow, is it the same depth everywhere? Is snow a uniform blanket on the surface? I think all of us who have played in the snow know that that's not true. We get snow drifts. We get areas where the snow is deeper, areas where the snow is shallow. And that's because there's different things like wind that make snow move. You can get blowing snow. And then this blowing snow gets trapped by vegetation, by perhaps some topography, a little rise or a hill. So you get some areas in the Arctic, especially, we can see in this photo, where there's actually no snow. All the snow has been blown clear, and you can see the tundra, the brown tundra underneath that. Then you can see other areas here that have meters and meters of snow, really deep drifts that form. So we really get this variable depth of snow on the surface. Where the snow is deeper, the ground is warmer. Where the snow is shallower, the soil is colder. That's because, as I mentioned before, snow is a really effective insulator of the soil underneath it. So we get this variability in snow depth, and that has important impacts for things underneath the snow. When you dig into the snow, if you've ever played in the snow and maybe dug a snow pit, looked at the snow grains, are all the snow crystals the same size and the same shape? Well, they're not. Snow is very layered, and the snow grains change their size, they change their shape during the course of the winter. That's because there's processes or things that happen within the snowpack that impact the physical structure of the snow. So when snow sits on the ground, it's not just a static, plain, boring old layer that just stays the same. It's constantly evolving because there's temperature gradients in the snowpack, there's moisture gradients in the snowpack, and it really changes how the snow crystals look during the course of a winter. So I'm showing you that here with some really kind of cool zoomed in photos. You can see the newest snow is in the top left. You can see those kind of classic 6-armed snowflakes that fall from the sky. Then they land and they interact with other snow crystals. They get maybe blown around by the wind or some intense sun shines on them. Then they start to decompose. They lose that classic snowflake shape, and the arms break off and they take on a more rounded form. That's what you can see kind of in the bottom right of this slide. And then by the end of the winter, if the snow stays on the ground for a long time, it actually starts to look like these cup shapes that are shown on the left, the bottom left here. And they get quite large, some cases maybe the size of your fingernails. So these are large, we call them faceted snow grains that are really, really very different from the snowflakes that fall at the beginning of the winter. So it's really, so we don't think of snow as kind of something that falls and then just sits there. It's very dynamic. It blows around, it changes shape and size. So it's pretty neat. And that's why we go into the Arctic and we measure the snow, because it's not always the same. It's not the same in certain locations. It changes a lot, and the vertical differences in the snowpack are important too. So we go up into the Arctic and we make these measurements. So where have I been lucky enough to go? These are just some of the communities in northern Canada where I've been over the past 20 years or so to make measurements of snow and ice on the surface. And we do this because we want to make sure that we're interpreting the satellite data correctly when we use data from space to monitor snow and ice on the surface. So we go out, we make measurements, we compare what we measure on the ground to what we see from space, and that gives us confidence that we can apply those satellite measurements across the entire Arctic, huge regions where we don't really have people living, so it's hard to get measurements on the surface. So when we're in the field, when we're in the Arctic, how do we live? Well, there's different types of experiments, different types of measurements that we do. Sometimes we live in a fixed field camp. So that's what this photo is showing here. These sort of tents in the top of the photo, they're there permanently. They're there year round, and we can fly in these small aircraft. This plane has little skis next to the wheels that might be hard to see. But we get dropped off in a camp like this. We have snowmobiles to help us move around, and then we'll stay here for a few weeks and go out every day on snowmobile and make measurements of the snow. So that's one way we tend to work in the Arctic. But sometimes we don't want to just stay in one place. So this is when it gets really fun. We bring our camp with us. So we pack up our tents. We have sleds that we tow behind our snowmobiles that we put all of our scientific instruments on, all of our extra clothes, our food, our gasoline for the snowmobiles, our camping gear, and then we can just go and we make measurements, and then we move our camp. So every day or every couple of days, we can relocate our camp. And that's really fun because we can get further away from where we start our measurements and sample across a larger area. So this is my favorite way to work in the Arctic. This is just a really neat photo we took one night when it was probably about minus 30 Celsius, so very cold. But we have a few little things in our tents to help keep us warm. And you can see some really beautiful things in the sky, in the night sky. That's the moon. And I think it was Mars or Venus is that bright planet beside the moon. And then in the top left, you can just see some northern lights starting to sort of tease us there in the sky. When we're in these camps, it gets a little cozy. So this is a photo of, that's me on the right here lying on my cot. You can just see the head of my colleague poking out on the bottom left from his sleeping bag. Gets pretty chilly in these tents, but we have a little heater we can use, and we have to hang up all of our gear to dry because it kind of gets wet during the day when you're working. So it's pretty crowded, it's pretty cozy, and you have to really get along well with the people that you're working with in the Arctic because you spend quite a bit of time in close confines with them. I must say it gets a little musty in here sometimes, a little stinky because everyone's kind of living in the same clothes day after day in pretty close quarters. But it is kind of a fun way to camp our way across the Arctic. So when we travel, we often travel by snowmobile. We have these sleds that we pull behind us with all of our scientific equipment, our food, everything as I mentioned, and then we can just bring everything with us. Sometimes we come across, this is crossing a lake in the Arctic where it had a big ice ridge, so the ice had come together. So you have to be careful sometimes in how you're traveling and pick a safe route on your snowmobile. This is a picture from near Eureka in the Canadian High Arctic of some of my colleagues here. We were actually towing an instrument behind the snowmobile. You can't really see it, but it measures the ice thickness as we drive. So it's kind of a cool way to make measurements of the ice thickness. Sometimes we travel by helicopter. So this is a picture of some blowing snow on a lake in the Canadian subarctic where we traveled around by helicopter. If we have longer distances to travel, it takes too long to do it by snowmobile. So we'll use a helicopter to get from site to site. This is another picture near Eureka. These are the Sawtooth Mountains, they're called in the background. That's me in the foreground making some measurements. And I always feel bad for our helicopter pilots because they have to sit and wait in their helicopter. This was about minus 40 Celsius this day. So that poor pilot's getting cold there, waiting for us. At least we get to move around when we're working and making our measurements. So what do we do? What kind of measurements do we make of the snowpack? Well, some of it's very simple. In this case, I'm walking here with a probe in my hand that measures the snow depth. It's kind of like a ski pole. You jam it in the snow till the probe hits the ground. You press a button and it automatically detects the depth of snow. So that makes it really easy for us to walk quickly and make measurements of the snow across the tundra. Sometimes you need to measure the thickness of the ice. And this is a great photo that shows how thick the ice actually is in the Arctic. So in this case, this is our ice auger on the left before we drill the hole. You can see it's about 2 meters, maybe even a bit taller, the auger. And then you got to get your arm muscles going, crank that auger down, drill a hole through the ice. And you can see we're just punching through the ice here. And you can see how much of that auger is now beneath the ice into the water. So this ice was about 2 meters thick. So pretty thick ice. When we look at the snowpack, we're not interested only in how deep the snow is, but as I mentioned at the beginning, the shape and the size of the snow crystals, that's actually important. It affects the measurements that the satellites make from space. So we're looking here very closely at the character of the snow grains. How big are they? What shape are they? What size are they? These are the kind of measurements we make as well. Very detailed measurements of the vertical properties of the snow. Sometimes we put instruments on an aircraft. So here you can see a plane flying very low in the background. It has instruments on the airplane that are very similar to the instruments that are in space. But unlike a satellite that is just in orbit of the Earth, with the plane, we can fly it anywhere we want and make very precise measurements that we then also use to compare it to the data from space. So really fun always to work with aircraft as well. This is a photo looking down. We dug a big trench in the snow at this site to look at how the snow properties were varying across about 10 or 15 meters. And we got a pretty cool photo from the aircraft. Interesting things we see. Well, the science is obviously very important. We're not doing research on wildlife when we're in the Arctic, but we do get to see some pretty cool animals from time to time. This is a flock of ptarmigan, which is kind of like a Arctic pigeon. They're very well camouflaged, as you can see, but they tend to hover together in groups. You can walk up very close to them. They don't get spooked very easily. I think they think they're always hidden, so they don't think you can see them, but of course you can. But you can always get really good photos of ptarmigan because you can walk up very close to them. They leave some pretty cool tracks in the snow. So these are ptarmigan footprints. They can fly, but they, for some reason, tend to prefer walking around unless they really get spooked. This is a really neat thing we saw where it looks like some animal, fairly heavy, probably a wolf, was walking across this ice when there was snow on top of the ice. So it compacted the snow underneath its footprints, much like you would do when you're walking in the snow with your boots on. But then it got windy and all the light, fluffy snow blew away, but the compressed snow underneath the footprints of the wolf stayed. So you could see the wolf tracks across the lake. I thought that was pretty neat. This is an Arctic hare. So we see a lot of these across the Arctic. They're also camouflaged very well. And they move pretty quick when they want to. This hare was being chased by a falcon, an Arctic falcon. And we stood and watched this hare get harassed by this bird for about 15 minutes. And I'm happy to report that it was safe. It managed to evade the falcon. But that was pretty fascinating to watch. We see a lot of caribou. So these travel in large herds across the Arctic. So we had a lot of interactions with caribou. They're pretty neat. You can see the really big racks on the male caribou. And maybe my favorite animal to see is the muskox. So these are quite unique to the Canadian high Arctic. These live about 80 degrees north, so really far north. They stay together in groups. They're quite cautious. They stay in a herd, but really just fascinating, beautiful animals. We see all sorts of weird things too. This is some scat from a polar bear. So we see poop, animal poop all over the place. It's pretty big. That's my big mitt. This mitt that I have here actually lying down beside that polar bear scat. One time we were digging a snow pit and a spider came out. I'm totally confused by what the spider was doing in the Arctic. I know nothing about spiders living in the Arctic, but apparently there's some species that are very hardy and can live in the soil underneath the snow. So that was pretty cool. And some polar bear tracks there on the right. They have some pretty big paws. We see lots of northern lights. This is a pretty special thing to see when we're there in the winter when it's dark. So I'm just going to move through these quite quickly. Put some northern lights photos. Pretty neat stuff. We had the really good fortune one time of camping with some Inuit elders in northern Canada. We stayed in our tents, which are kind of in the background here. They built this wonderful igloo. They would invite us into their igloo every night for some hot tea and some snacks together. And one night we had just beautiful northern lights with their igloo in the foreground. It was a pretty special memory. And this is called a sundog. So we see this occasionally. You can see kind of like rainbows around the sun. So the sun is behind my colleague Peter's head here. So he's blocking out the sun, and you can see the two sundogs on either side, which is pretty amazing. These are created by ice crystals. When the atmosphere is really, really cold and there's really small ice crystals in the atmosphere, you can get a sundog like this. Okay, so that's my travel log, my photos showing you my experiences that I've had in the Arctic. It really, truly is a wonderful, special place. But since the theme of this month was exploring, and of course this is exploring by the seat of your pants, I thought I would just share a couple thoughts really quickly on what makes somebody an explorer. Can we still be an explorer today, even though most of our world has been explored already? And I say, of course you can. And I really think there's just 4 things I want to emphasize here. Number 1, you're an explorer when you do something that's pushing you out of your comfort zone. So when I go on some of these trips, I'm away from my family for a long time. It's very cold, very uncomfortable. Sometimes it's a bad storm, so you get a little bit nervous about how things are going. That makes me uncomfortable, but that's part of the thrill of it. It's part of the enjoyment of doing something. Is like, I haven't done this before. This is a new experience. I really think that's something we always need to push for and try and experience. When you put all of your energy and focus into a passion of yours, something you really like, a sport you play, some subject in school, that's being an explorer. That's really pushing your limits and pushing how much you can learn about something. That's always great to do that. You should share what you've learned, what you've experienced with other people. That sharing experience is part of being an explorer as well, I would say. And then finally, it's really helpful when you can find a mentor. So a mentor means somebody who can teach you and support you and help you learn about something that you have a passion for. So in the top photo here, that's one of my mentors. His name is Arvids. When I first went to the Arctic in 1994, he was with me. He was working as part of the same project, and we still go to the Arctic together now. He has a lot more experience than I do, so I've always learned a lot from working with him. And on the bottom here, this is my colleague Matthew. I first went to the Arctic with him in 2007, and he just taught me an incredible amount about measuring snow, the physics of snow. He's the person actually who wrote this book, The Field Guide to Snow. He's really a world expert in snow, and I've learned so much from him and benefited so much from spending time with him in the Arctic. So find a mentor, and if you can, support others who have similar interests in you. So I just wanted to close with these 4 comments. I hope that my photos and a few stories about being in the Arctic and traveling across the Arctic have sparked some interest in you. I'm happy to answer any kind of questions you might have. And I also just thought I would leave this here for your teachers. There's a lot of online resources to help engage students and instruct them on what's called the cryosphere. So this is any part of the Earth's surface that's covered in snow or ice, sea ice sheets, freshwater ice, permafrost. It's a really dynamic field of science these days, and there's some good online resources, including the link here on this slide that, depending on the grade level, you might be able to find some helpful resources there. So thanks to Jesse for introducing me, and thanks for the opportunity to present to all of you today. I hope you enjoyed it, and I'm happy to answer any questions you might have. And I'm going to stop my screen sharing because I can't see Jesse or you when I'm in my...
More fun to see us, Chris. Yeah. So
yeah.
Feel free to do that. That was fantastic, man. Thank you so much. What we're going to dive in with, before we dive in with Q&A, we're already getting a bunch of great questions coming in on YouTube, which is awesome. Is we're going to do that little Kahoot quiz. So at the beginning, I mentioned if you guys want to get kahoot.it, kahoot.com up, little 4-question quiz based on Chris's presentation. See how much you were paying attention. For those new to Kahoot, the faster you answer, the more points you get. Now, you don't win anything, but you do win Chris and I's everlasting respect if you win. So no pressure there, but it should be a lot of fun. I'll pull that up right now while you guys are coming in. Awesome. We're already getting a bunch of people participating. And of course, if you don't have the opportunity to do a Kahoot, you can just play along with these questions in your class. Chris, before we dive into, if you are able to get me in the private chat in StreamYard, the link that you had on that final slide, the way that slide was formatted and didn't show up, and then I can make sure all our classes have it as well. So that would be great. All right. And then while we're waiting and while we're doing this Kahoot, guys, over the next couple of minutes, get those questions ready. I look forward to hearing from you guys the moment we're done. All right, over 50 folks. I'm going to start us off. More of you can join as we get underway. But here we go. And Chris, we can help them out when there's a few seconds to spare in each of these.
Okay, I'll do my best.
Our first question, a multi-select, so it's more than one answer. What are some of the reasons that snow is important? Back to the earliest part of our talk today. It's a good insulator. Its brightness reflects sunlight back. You can make wicked awesome snowmen, or it provides fresh water when it melts. Now, one of these is important, don't get me wrong. It's one of my favorite things to do with snow. In the context of climate change up in the Arctic and going and exploring, might not be as big. I don't know, we had 85 of you, so awesome. Our snowmen, there are 15 of you who thought snowmen were awesome, and they are. But our other three answers are our main ones, of course. Nimble Pigeon currently in the lead. All right, perfect. And if you want to let us know who you are at the end, please do in the chat on YouTube or live with us on StreamYard. What are animals Chris might come upon in the Arctic? I'm going to go out on a limb and guess that the picture that I've done is meant as a gag. We'll see. Tiger, caribou, wolverines, or penguins. So click any that apply. You ever seen a wolverine? Have you ever seen a wolverine track, Chris?
They're pretty cool animals. I've never been up close to a wolverine because they're very skittish. They don't like to get close to humans. But they are really cool. They're pretty ferocious little suckers. They got big claws. Yeah, they're really neat.
I think pound for pound, they're like the most powerful, like crazy animal. They take down caribou, which is wild. We've only had a couple of programs, but people search their whole lives for wolverines and see like one. So
scrappy.
A lot of you got caribou right. Wolverine's good. Penguins are only in the southern hemisphere, so no penguins up in the Arctic where Chris gets to go. Only in Antarctica and other places like that. All right, Dr. Buffalo taking the lead. Number 3. Here we go. Multi-select again. I got really into the multi-select today. What are essential parts of Chris's field kit? What does he need when he goes out on these epic adventures? Warm jacket, snow probe, fancy car, snowmobile, or snow machine for those who want to call it that instead. 11 seconds. Man, over 100 of you are joining. This is awesome today. Way to go, everybody. All right. You saw some of these in quite a few of the pictures. What do we think? Maybe cool helicopter I should have put. She has fancy car, not necessary. The other 3 all are. Way to go, everybody. Giving us a new lead. Dr. Buffalo keeps the lead with 1 more to go. Okay, true or false? Learn more about climate change. Snow is important. This is the theme of the talk, so I'm very much hoping you guys nailed this one. This is a very important question. You have 4 seconds left. So many of you today. Way to go. It's one of our biggest Kahoots ever, Chris. So yes, awesome. 3 of you thought false, but I think we nailed the 99%, which is good. All right, our podium before we dive into that Q&A. Whew. I'm excited. I'm going to head to Mrs. Nick's class first when we dive in with our questions. So get ready, Miss Nick. All right, Nimble Pigeon from the beginning. Oh, did Dr. Buffalo win? We're going to find out. Dr. Buffalo won. If you are Dr. Buffalo or Agent Panther or Nimble Pigeon, let us know. We'd love to hear from you. Chris, that was a lot of fun. Let's head to Miss Nick's class, our first of 2 Wisconsin groups today. So, Miss Nick, if you guys want to come on up in Green Bay, you're good to go. Hey, guys.
Sure. Lauren, do you want to stand up here a little bit closer so they can see you? Okay.
What is the coldest temperature you have ever been in?
That's a great question. So when I went to Eureka, which is in the Canadian high Arctic, it was minus 45 Celsius. So I know you're in Wisconsin. Once it gets this cold, my Celsius to Fahrenheit conversion isn't good. It's just really, really cold. And we were outside and we had to try to get our snowmobiles to start after they've been sitting there. And it's really hard to start a cold snowmobile. So we pulled and pulled and pulled. Finally got one started, and I didn't have my face properly covered, and I just took a little zip around on the snowmobile, and in that about 5 seconds, the tip of my nose froze solid. So it went white, and it was like, it felt really weird. I managed to freeze my nose in a very short amount of time. So I've never had really bad frostbite, and that was a short period of time, so it wasn't too bad. But that was really, really cold, and I really froze my face in a short amount of time. So about minus 45. Yeah, that's plenty cold for me.
I would say so. I like you. Actually, you're at the point where basically Celsius and Fahrenheit become similar, and minus 40 is where they're identical. So our Wisconsin folks might actually be fairly used to this. But any temperature where you can throw water in the air and it freezes before it hits the ground is it's too cold. Great first question, guys. All right, Flemington, New Jersey, Miss Jody's class. We're gonna head to you guys now. Come on in. Hey.
Have you ever seen a polar bear?
That's a great question. Yeah, I have seen a polar bear twice in my life, one of which was maybe a bit too close. It was the second time I was ever in the Arctic, and we were sleeping at night in a tent. And when it's windy, the tents shake in the Arctic, so you don't think too much about it. But then I woke up in the middle of the night and the tent was shaking, but it wasn't like a windy kind of flapping shake. It was like a rhythmic sort of shaking. And we realized that a polar bear was up on its hind legs and was leaning and pushing against the frame of the tent. So we managed to make some noise and scare it off, but we were very close, and it's a bit unnerving to be that close. We do travel, and we're trained to. We have shotguns, and we have other things with us to help us defend ourselves against polar bears. We don't ever want to use them, and I'm fortunate enough to say I've never had to use it, but we are prepared in case. And so, yeah, I've had a couple of close run-ins with bears. That was plenty close enough for me. But they are beautiful.
They are, and I'm glad. I was actually going to ask the question about what sort of training you guys have, and so that's a pretty standard thing when people go up to Arctic exploration is they have weapons, they have things to help themselves if need be. That is the diciest story of anyone we've ever talked to about a polar bear. Like, it's very bad if it ends up against the tent.
Yeah. I was too young. I was too young to realize how scary it was. It was only my second time in the Arctic. I thought, oh, it's the polar bear. That's okay. I've hardly seen one since.
Okay. We've had the Toronto Zoo talk about polar bears before, and being where you turn and it's just looking at you through the glass, where its head fills the entire frame and it's the size of your torso, is plenty scary enough. Yeah. Cool. That was Chris, it's wild. PCMS, our folks in Pulaski, we've got an entire auditorium in Wisconsin. We got like half the town, I think. If you guys want to come up for a couple questions, we'll go to you guys for 2 in a row, and then we'll go to Miss Forsyth and Bracebridge next. PCMS, welcome in, Mr. Landers. Awesome, go for it, man.
All right, nice and loud.
Have you ever been chased by an animal on your snowmobile?
Yeah, I don't think I've ever been chased by an animal. We try to be very respectful of animals, so it's like we want to take photos. Like anybody, if you see a muskox or a herd of caribou, or even like a hare, you want to get close to the animal to take some nice photos. At the same time, these animals like caribou and muskox, when they have to run across the snow, they expend a lot of energy. They don't really want to run. They prefer to walk. And so we're always trying to be not to spook them with our snowmobiles, because the engine noise from the snow machine will get them running. So we always try to keep a distance and take nice photos, but stay back and not get them running. And I'm happy to say I've never actually been chased by an animal. That's a great question.
Oh dear. I was wondering if any of the birds ever actually, that was one of my big questions, is like you have things like falcons up there that might be protecting a nest. Is there like any context in which you've ever heard of that happening to anyone where a bird comes to attack people?
We haven't been dive bombed before. No, I haven't. But you do see it. It is always strange sometimes. You're in the middle of nowhere and you see these birds just kind of flying by and you wonder, where are you going? Where are you coming from? Where is your nest? It's very unusual.
Almost as strange as the spider. We're going to have to follow up on that.
Yes.
All right, PCMS, coming back to you guys for another one. Hey. If you guys want to do it quick here, go for it. Yeah, you guys are great.
Do the animals ever when you see the animals, do you ever add them to your data?
Yeah, that's a great question. So what we often do is we take photos of the animals and make notes, and then we send it to our colleagues. So at Environment Canada, for instance, there's a whole other group of researchers who focus on studying animals in the Arctic, polar bears, birds, you name it, they study it, wolves. So what we do is try and take pictures if we see anything unusual and send it to them. And in fact, one time, one of my colleagues saw on the side of a big rock this really cool bird's nest. And he took a picture of it and sent it to our colleagues. And it actually was the nest of a bird called a barn swallow, which is not a bird that's usually found in the Arctic. So the bird scientists were really fascinated to get this photo, and it was a really unusual sighting. And they think it's evidence that some of these birds are starting to change. We know this is happening with some animals. They're changing where they live because of climate change. When it's warmer in the Arctic, some of these animals are moving further north. So yeah, so we don't study the animals ourselves, but we try to help our other scientists who do by documenting and taking notes and photos of anything we see that seems unusual to us.
Yeah. And I love this. I mean, one of the things that you guys might have noticed with the helicopters and the snowmobiles, it's expensive to mount a big Arctic expedition. And so it's important to make sure that, other scientists around the globe get to collaborate and understand what's going on. And so that's one of the big essences of the scientific community is that you get the chance to work with so many amazing people around the globe and collaborate with people worldwide across Canada and beyond. So it's, I'm really glad we got that question. Thanks, guys.
Yeah, awesome.
Right. Oh, a quick note too for collecting your own data. Sorry, you're talking about getting pictures of animals. For our classes, if you've never heard of or used the iNaturalist or Seek apps and you want to collect your own data of local wildlife and see what lives near you, those are the best tools we've ever seen in action, and we absolutely love them, especially in May for our backyard bio program. Just a quick plug. Miss Forsyth's class, let's do our grade 9s in Bracebridge. Come on in, you guys.
Hi, can you hear us?
Yeah, perfectly.
Yep. We'd like to know like your qualifications, like what was your post-secondary plans to get you this type of cool job?
Yeah, excellent question. So I went to university to study physical geography. That was what my undergraduate degree was in. And I went to a university that has a co-op program. So that means I did 4 months of school, 4 months of work, 4 months of school. And one of those work terms was with a professor who was doing research in the Arctic, and that's where I got to go up as a student, as a second-year undergraduate student. So I was really lucky to get up north at that age, and then it just really I wanted to keep studying and learning more about the Arctic. So I did a master's degree, and then I did a PhD degree as well. So I have a doctorate, and that's become really my life's focus is working on snow. But you don't have to have a PhD or a doctorate to do this kind of work. We work with all sorts of people from all different backgrounds, all different types of focus in the work they do. Our research team has people from different backgrounds. So definitely you need to stay in school for a while, get some school time in there, but lots of different ways you can get into Arctic science if that is interesting to you.
Yeah, there's two things that you mentioned there that I really love to harp on. One is the fact that you got the chance to go and do the actual work as a student, which is rare and unique and fantastic. I really do. Our grade 9 class today, we've got some other high school groups that are joining in on YouTube. Get those opportunities. All the scientists that we feature on these programs pretty much universally got the chance to go into the field or do something or talk to someone and work with them directly before they ended up with the professional qualifications to do so. And it really makes such a world of difference. So I'm glad you had a chance.
I'll say one more thing. Don't be afraid to ask people for opportunities. I was a very shy undergraduate student. So I was like 19 years old, and I had this professor who was studying the Arctic, and he seemed very intimidating to me. And I was afraid to talk to him, honestly. But then I just ran into him one day outside his office, and I worked up the nerve to ask him if he was ever hired students to work in his field camps. And he said, yeah, sure I do. And so I always think if I had been too afraid to ask him that question, what I would have missed out on in life, right? So I know it's hard. It's hard sometimes to be forward and to ask people questions, but if there's something that interests you and you want to do it, just ask people. Most people are really nice and supportive and helpful.
I mean, for our students today, imagine going up to Chris and asking him if there are school opportunities. I think you get a pretty sincere yes, right? Like, I mean, it again, pretty much universal. I'm so glad you shared that. That's fantastic. Thank you, Chris. We're going to take a couple from YouTube, and then we're going to go back to our live class. Right. We're ripping through these. This is like a record speed broadcast. I love it. So Miss Nagel's class from all over the Guelph area in Ontario. So many questions. Okay, Mo wants to know a serious question for you. Do you guys just like not shower for a couple of weeks? What's the hygiene up there?
That's a great question. It's true. In some situations, we do not shower. And my personal record, not to share too much information, but my personal record is 24 days between showers. That's a long time. And so I'm sure me and my colleagues, we didn't really enjoy days 20 to 24. But when you're all a little funky, you don't notice it so much. And we do. You have to take care. We bring things along to help keep basic hygiene going. And so a long time between showers, but we bring lots of spare clothes. I have to change my socks an awful lot. We do have different layers that we can sample in and out of. So yeah, but you do have to suspend your normal expectations for frequency of showering. There's no other way around it.
The bending over backwards to explain ways in which you do keep hygiene up makes it seem worse. All right, one more from YouTube, and then we're going to go back to Miss Nick's class. When you measure snow, do you do it in several different places at each location to get an average? This is from Brock and Miss Nagel's group.
That's an awesome question, Brock. Yeah, that's exactly right. We never, ever do things in one place. You always do repeat sampling. in different areas, and then we can then understand, well, maybe we picked a not really great spot to make that measurement, so we can average data together. We refer to it as the sample size. When you're doing science, no matter what field of science you're in, no scientist is ever happy with a small sample size. You want as large a sample size as is practical to get. So, we can't make hundreds and hundreds of measurements in one spot because we have to keep moving, but we will definitely sample in multiple places so we can compare those locations to each other. So that's a fantastic question.
Yeah, you'd probably want to do hundreds of measurements, but the helicopter pilot would just fly away at that point.
Yeah, we don't want to be left behind. We got to keep it moving. Yeah.
We're gonna head back to Miss Nick. I do want to note some of our classes might have to go in the next minute, so I want to note that if you guys do have to go, if you have more questions after the fact that you don't get answered today, head to the Padlet for today's program. So just our initials/snow. We'll be checking that over the next 2 days if you have more questions to share, and we look forward to your questions there. If you've never used Padlet before, feel free to reach out and we'll let you know how it all works. But Miss Nick, come on back in Green Bay. Unmute your mic and you're all set.
Okay. All right, do you have your question?
Have you seen a muskox herd defend itself?
Oh, cool question.
That's a great question. Yeah, so muskox, when they are threatened, they do a very kind of like a buffalo. They get into a circle, and so their butts in, heads facing out, and they take their young, if they have calves with them, they put them in the middle of the circle. So they have a very distinct style to defend themselves, and they're pretty smart. As soon as they hear the sound of a snowmobile or they sense a human nearby or smell you nearby, they will get into their defensive posture very, very quickly and protect their young. Now, of course, that works very well against. So the reason they developed that strategy was to defend against wolves. So wolves will hunt in packs, and wolves can take down a muskox if it gets separated from its herd. But when they're in a circle like that, they can work together and kind of move and protect themselves from the wolves. It doesn't work so well against humans if you have a firearm, right? And so that's why in certain eras and certain locations, muskox were decimated by human hunting, because it's a great defensive posture against animals. It's not a great strategy against humans.
Yeah. Well, I think that the student you would have underpinned with that knowledge. So if you guys have never seen muskox defend themselves, it's such an amazing thing. It's one of the most incredible things in nature. There's a series in the last couple of years, 7 Worlds, 1 Planet. Their North America episode has muskox in the Canadian Arctic. It's one of the most incredible pieces of footage you will ever see ever. I bet the clip's on YouTube, and I'll try and find it for you guys after the broadcast as well. So very, very cool. All right, Miss Jody, we're coming back to you, and then PCMS and Miss Forsyth in that order. But Flemington, come on back in. Hey, guys.
Have you ever saw an animal that you couldn't identify?
Oh, you're putting me on the spot. That's an excellent question. Well, I'm not very good at identifying types of birds, that's for sure. I'm trying to think. I don't think I've seen an animal we couldn't identify. I will tell kind of a weird story. One time we were in the middle of the forest, actually, so like kind of high tree, close to the tree line. In northern Manitoba in Canada, we were just digging snow in the forest, and about halfway down in the snow pit, there was a layer of like brown, yellow snow, like a crusty layer of snow. And we could not, and I still to this day don't know exactly, and it was we dug a few other snow pits, and we could not figure out what it was, and I still don't understand to this day what it was. So we do sometimes see mysterious things, and not always animals, but other things that we just have to shrug and go, well, I don't know what that one is. I'll take a picture of it and show it to other people when I get home and see if they can figure it out.
Yeah. How neat is that? I'm trying to think of the scientists we work with that might know things about that. But if there's a picture that still exists, send it to me. We'll see how it goes.
All right.
Cool. All right, PCMS. We're going to head back to you guys for 2, and Miss Forsyth to wrap up. Great question, guys.
How many times have you been to the Arctic?
That's an awesome question. Yeah, I've been to the Arctic, I think now about 25 times. And so almost every year since 1994, with a few gaps here and there. And we've had to cancel all of our trips to the north the last 2 years. But we're hoping that this spring, because we usually go to the Arctic in like March, April, May, that sort of time period, when there's more sunlight and it's a little bit easier to work. So we're hoping to get back. We have plans to go back this year. We'll wait to see. We have to be careful we wouldn't want to introduce COVID to some of the northern communities because they're quite isolated and quite small. So there's a lot of rules in place right now for people from southern Canada going to northern Canada. but things are improving slowly, and so we're hopeful to get back up there soon.
We certainly hope you get that chance. And yeah, one of the things you mentioned that I really love is the idea of going when there's sunlight. So the area of the Arctic that you go to in the winter can be perpetual darkness, or at least mostly darkness, correct? Right?
Yeah, that's right. Yeah. So when we go, we've gone sometimes like in December, and you never see the sun. It maybe gets a bit dusky, but it stays pretty dark all day. And then the nice thing is by May, when you're working in a lot of these places, the sun never sets. So you get beautiful working conditions all day long. Makes sleeping a little bit tricky. You got to train your brain to calm down and fall asleep when it's still light outside. That's a bit odd, but yeah, it's pretty amazing stuff.
Very cool. All right, PCM has one more from you guys. Come on back in. Hey.
Hey.
If you could estimate, how many animals do you think live in the Arctic?
Ooh, no pressure.
Ooh, that's a good question. So there's like, the key big ones that everybody thinks about: caribou, muskox, wolverines, foxes, wolves, those sorts of things. Those are but there's not that many of those different species of like large mammals and birds. Yeah, maybe a few dozen. I could be totally wrong since I'm not really a wildlife expert. But what's really interesting is thinking about like what lives in the ocean as well, and the small little critters, the fish. There's a lot going on beneath the ice that we don't always see. So we're pretty good at seeing what's happening, up on top of the surface. But I mentioned there's some animals actually that live in the snow. So lemmings are little mice type things that burrow and dig tunnels in the snow. So they're hard to spot. And there's just so much going on in lakes and in the ocean beneath the ice. I've seen some footage of people who've gone diving, like scuba diving beneath the ice. It's pretty amazing stuff. So yeah, lots going on and lots still to learn.
I want to encourage our classes when you're done this broadcast. Now, one of these scientists, our first one, goes up to the Arctic regularly. He's a botanist. He explores all the plant life there. And then talking about underneath the ice, Hugh Griffiths, our second guy, goes to the Antarctic and explores the marine biodiversity underneath the surface. It is mind-blowing how many incredible and wild and unique creatures live under the ice in Antarctica. So Arctic, not quite as many, but some really, really amazing species. I really encourage our classes to check out those programs on our YouTube channel. Miss Forsyth, we're going to wrap up with you. Time flies and you're having fun, folks, but come on in for one last question. Hey.
Sort of a two-part question. Are we doomed in terms of damaging the Arctic with climate change? And what would you suggest students in Canada and the US can do to minimize global warming and climate change?
Yeah, that's an awesome question. That's a great way to finish as well. And so I would say I try to avoid using sort of doom and gloom language, but I also don't want to sugarcoat things. So climate change is a real phenomenon. It's having a real impact in northern regions, especially. And so this does, the changes that we're seeing to snow and ice because of climate change, it does affect, for people who live in the north, it affects their ability to travel, to get to their traditional hunting grounds. It affects the wildlife. So the impacts are serious. So we need to consider it. At the same time, there is examples in the past of the international community coming together to solve really important environmental issues and challenges. So I'm old enough that I remember when acid rain was a really important issue, especially in Canada, and that was addressed. More recently, there was the ozone hole, where there was changes made to how certain chemicals are used that has really been successful in reducing damage to the ozone layer in the atmosphere. So my hope is that we can achieve something similar with climate change, where governments can come together and understand what needs to be done. I think we understand the science, we understand what needs to be done. So it's just a matter of kind of motivating people to move forward. And so there's important things that need to happen at very high levels, but there's always things that we can do as individuals to help the climate change problem as well. And so I won't go into all the details of what that is, but if you can cut down on things that use fossil fuels, if you can be responsible with how you decide to live certain aspects of your life, you don't have to change everything, but just identify a couple of things that you can change or your family can change to help. If you add up a lot of small little changes, it adds up into something substantial. So we all have things we can do individually, and then we all have things that we need and we hope to have happen on a more collective level. So it's not, I wouldn't say we're doomed, but I also think that people need to understand that this is a serious issue and that we need to work together to solve it.
It's my very favorite question that we get to end broadcast. I want to stress for Ms. Forsyth's class, for all of our classes, actually, 2 amazing resources to check out, both by the same author and sort of a consortium of international scientists, are drawdown.org, regeneration.org, talking about some of the solutions that you can do, talking about the fact that we're very much not doomed, and there's been so much positive effort, especially in the last 20 years, to make a positive difference. I mean, if you look at the energy produced in the world, wind and solar are far and away the fastest growing ways of generating energy on this planet. They're also the cheapest. So we expect to be in a really much better situation in the next decades to come, just based on cost alone. You know, and your generation are the ones that's really leading the charge. Chris and I love that you mentioned acid rain. Acid rain was so big when I was a kid. And again, we did so much to help stop that. The ozone depletion was done because of a huge amount of political will that changed that in a few years, that made a really big positive difference. And we're seeing that across the globe. Kids your age are leading 500,000 kid marches to talk about the impacts of climate change. You guys know the facts, you're really vested, and there's been this shift in 20 years, a massive shift in the public consciousness around this. So it really, we're going to have a lot of challenges to face, but I think the best way of thinking about it is it's the greatest challenge we've ever faced as a species. We really are coming together to do it collectively. So it's an exciting opportunity as well as a big challenge that we're going to have to face. So Chris, thank you so much for that answer and for sharing all your insights and fun stories with us today. This has been fantastic. Is there a final message about exploring snow and ice, about Arctic exploration that you want to leave us with before we wrap up?
Oh, that's a tough one. There's lots I could say. I'll just say thanks for the opportunity to present to you. I hope that my slides, showed you some of the unique aspects of life in the Arctic. I didn't get to talk much about the communities in the North. So, there's really rich history of communities in the North and people in the North doing amazing things. So it really is just a wonderful landscape there, wonderful people. If you have the chance ever to get into either Alaska or Northern Canada or Northern Europe, please take it. It's a fascinating place. So that's that piece. And the only other thing to say is let's all continue to talk together, to share ideas, and to work together, because that's how we can solve complex problems, by communicating about it. So let's just keep talking to each other.
Chris, you rock, man. This is a fantastic program. And as you know from your last broadcast with us, what we're going to do to end is bring in all our teachers to say a big thank you and farewell. PCMS, we got a whole auditorium. I'm excited for your energy. Miss Nick's class, Miss Forsyth's class, PCMS, thank you all so much for being here today. Have a wonderful day, everyone.